Good afternoon, everyone. Today, our project is about airline route optimization using Floyd-Warshall Algorithm. In this project, we are using the Floyd-Warshall Algorithm to find the shortest paths between a set of airports and visualize the result using a graph. The purpose of this project is to showcase how algorithms can be used to solve real-world problems and how visualization can help in understanding complex data. We will be exploring the steps involved in implementing the project, including generating random distances between airports, creating a distance matrix, running the Floyd-Warshall algorithm, and visualizing the result using a graph. This project can also be used in several applications, which we will talk about further in the presentation. Overall, the project demonstrates the power of algorithms and visualization in solving real-world problems and the potential of future research and application field. Moving on.
Okay, let me give you the introduction for the project. The project can be useful in several applications such as optimizing airline routes, transportation planning, and logistic management. It can be used to study the connectivity between the different cities and the region and to identify the potential hub of transportation and commerce. The problem is to find the shortest distance between airports using the Floyd algorithm. This is an important problem to solve because it can help optimize air travel routes by identifying the most efficient paths between airports. It can be improved flight planning, scheduling, and providing accurate distance and the time estimates. It can also be led in predicting flight times and delays, which is crucial for airlines and especially for the passenger and the airport operations. By solving the problem, we can potentially reduce the travel time, save fuel costs, and improve the overall efficiency and the sustainability of air travels. Let me move to the next slide.
So the methodology of our project is as follows. We use artificial data sets to stimulate real-life scenarios. We generated random distances between airports for our project. We use Floyd-Warshall algorithm to find the shortest path between the airports. We also utilized graph visualizations to show the results of the shortest path between the airports using a graph. For our code overview, we use 3 different libraries, Python libraries, which are NumPy for our numerical computations to generate and manipulate the random distance metrics. We use NetworkX to use graph manipulation and analysis, finding the shortest path using the Floyd-Warshall algorithm. We also utilize Matplotlib to visualize the data and the shortest path on the graph. Moving on to our Floyd-Warshall algorithm,
The Floyd-Warshall algorithm is a dynamic programming algorithm used to find the shortest path between all pairs of nodes in a graph. It uses a matrix to keep track of the shortest distance between all pairs of nodes in a graph. The algorithm works by comparing the distance between 2 nodes and the distance through an intermediate node, and selecting the shortest order of 2. Usually, the time complexity of the Floyd-Warshall algorithm is n raised to 3, where n is the number of nodes in the graph. It is also more efficient than other algorithms for finding the shortest path in dense graphs. Although the time complexity is higher than the other shorter path, it is still considered to be more efficient. Moving on.
These are the following libraries we use for our project. NumPy, for example, is used for multi-dimension arrays and matrices and to calculating all the mathematical problems. We also use NetworkX to do the graphs and study the complex networks. Also, we use the Matplotlib for creating visualizations such as graphs and plots. Moving on to our results.
The graph is visualization representative of the shortest path between the airports in the dataset. Each node in the graph represents an airport, and the edge between the nodes represent the shortest path between them. The size of each node represents in its degree or how many connections it has to the other airports. The color of each node represents its centrality or how important it is within the network. The thickness of the edge represents the distance between airport and the thicker edge representing shorter distance.
Here we would like to talk about a few applications of airline route optimization. Optimizing air travel routes to reduce travel times and fuel costs. We can also predict flight times more accurately to improve airline schedule and reduce delays. Improve air traffic control systems to reduce congestion and increase safety. Identify areas for infrastructure improvements such as the construction of new airports or runways or tarmacs. Examples of real world applications would also include when American Airlines used a similar optimization approach to improve its scheduling system and reduce delays by 25%. Another example would be the Federal Aviation Administration FAA uses network flow algorithms to manage air traffic and reduce congestion at major airports, like the airport of Atlanta itself. With the increasing demand of air travel, airline route optimization has become an essential area of research in aviation industry, especially when it is so costly. Moving on
to the future work that we can use the real world data, flight data, to generate a distance between airports, expand the scope of our project to include multiple continents or even on a global scale, implement additional algorithms for comparison and optimization. We can also explore the potential for machine learning applications, and that's about it. And for our conclusion, we have also successfully demonstrated the effectiveness of Floyd-Warshall algorithm in finding the shortest path between airports, showcase potential for algorithms to optimize air travel routes and improve the efficiency of our aviation system. I highlighted the importance of efficient air travel routes for reducing travel times, improving safety, and reducing environmental impacts. We also demonstrated the usefulness of Python libraries for data analysis and visualization tasks.
Thank you for listening to us. We would now like to show you a program and how it actually works and talk a little bit about it. So we're going to move on to our program now.
Hey guys, this is the code we wrote for our project, and we defined 4 airports with minimum distance 100 and maximum distance 1000 for a range of distances. And then we create a list of our airports using a for loop. Then we create a dictionary to store the distances. Then we use a random library that we can use artificial data sets to store the distances between airports. We could also use real life data sets, but we need to incorporate the APIs and other data sets that we had to find. But anyways, we just use the random data for our project. And moving on, we initialize the distance metrics with the distance between each pair of airports. In these for loops, this is where we perform all the matrix stuff. Moving on, we have our Floyd-Warshall algorithm. We have these 3 for loops that we use to calculate our implement our Floyd-Warshall algorithm. And at the end, we incorporated NetworkX library that we can use to display our metrics and the graph we can show at the end. Here is the demo of our project, and it shows all the nodes of the airports and the graph in general, and it shows the shortest path between airport 1 and airport 4 is 233 kilometers. And similarly, airport 3, airport 4 has the second shortest part is 255, and we can see the other ones as well. As it generates the random data, we can rerun it and check for different airports again. Similarly, this airport 1 and airport 3 has the shortest path. We can check again. There we go. We can see airport 3 and airport 1 has the shortest path. Thank you very much. Thank you for listening.